Now, much of the world's population live and farms in dry land, arid or semi-arid environment that covers about 40% of the Earth's land surface. And precipitation in this region is very little, so meager that the dry lands are prone to desertification. So this word here, desertification, is a phenomenon that describes a form of land degradation in which more than 10% of the productivity is lost as a result of erosion. Could be soil compaction, forest removal, overgrazing, drought, climate change, water depletion, and other factors. But most of this degradation comes from the wind and water erosion. So several desertification can expand existing desert areas, that the word suggests, right, and create new deserts. And these processes have occurred most dramatically in the areas of Middle East. You have learned this from a few slides ago, in the Fertile Crescent region, right? Yeah, where agriculture first originated. And look what's happening now. They become deserts. Now, raising livestock has some impacts on soil and ecosystem. When the sheep, goats, cattle, and other livestock graze on the open range, they feed primarily on grass. Right? Most of them eat grass, not us. And as long as the livestock populations do not exceed the rangeland's carrying capacity, there's always limit to the amount of food there are, and do not consume grass faster than it can regrow, then grazing might be sustainable. Now, when too many livestock destroy too much of the plant cover, they will slow down the plant regrowth and preventing replacement of the biomass. That's what we call overgrazing. And when the livestock remove too much plant cover by stomping and other actions, the soil is exposed and they're made very vulnerable to erosion. So in a positive feedback, right, the soil erosion makes it difficult for the vegetation to regrow, and this is a problem that perpetuates to the lack of cover and give rise to even more erosion. So it's like a negative cycle, it just go downhill so bad. And on top of that, the non-native weedy plants, the weeds, right, that doesn't taste good to the cattle, not very palatable to them, they may invade and even outcompete the native vegetations in the new modified environment. And too many of these livestock, they trample on the ground, they will also compact the soil too much, right, the action of the force, and alter the structure. So what happens when you compact soil? You make it more difficult for the water to infiltrate the roots, to conduct cellular respiration, and we know that water is a solvent to dissolve the nutrients there, uptake by the roots, and all these factors will continue to decrease the growth and survival of native plants. Now let's talk about some environmental properties of soil, as we have discussed just now. One key thing is the leaching and erosion. One key point is leaching and erosion, leaching of nutrients, erosion, washing by the wind and the water. In the soil, the nutrients present there in terms of the ions, they could have reactions with the acid or bases. So typically carbonate, CO3 2-, they are basic, so they will cause the pH of the soil to become on the higher side, about 7.5 to 8. And if you have some exchange with aluminum 3+, because of the high charge density alongside with the iron 3, they will cause the organic matter to be a little bit acidic, lower pH. You can use the equation and write down the partial hydrolysis of the water due to the small sized ions. And for the microorganisms whose respiration produce the carbon dioxide and they produce some organic acid by these microbes, right, they result in lower pH than 7. Same goes to anthropogenic sources. So here we have one equation there that shows the slightly acidic ammonium, right, reaction with oxygen from the air and also on the surface of the water, soil, water, and it forms a nitrite ion with the base of H+. So again, it will cause the soil to be even a bit more acidic. We can't leave out geochemical reactions, the limestone, calcium carbonate. You can quote marble, reaction with the acid to form calcium sulfate. These two might combine at a higher concentration to form a precipitate, clogging the soil. And other biological processes that will neutralize the acidity of the soil in the roots could be the carbonate CO3 2-, CO3 2- in acid and nitrite will form a bicarbonate. And there may be other trace metals in the soil. What are the trace metals? Now, in the trace metals in soil, typically we are talking about the metals. So they came from the original minerals that were subjected to weathering, like from the rocks or from other sources. So this soil has the trace metals. It could come from many sources. It can be carried from a rain, wash off, run away, river, tributaries. Now the metals can also be deposited by specific sorption processes on the surface of the minerals, or could be from mankind, from pollution. So these metals are retained together with the minerals because of their cationic nature, positive nature. So they will have some exchange site in the plants, because we saw just now that ammonium cationic, and we have some ions that have similar sizes and charge. The plants might not selectively absorb these. So these metals could even be found in the pore water of any soil. In summary, for the cation metals, trace metals here, you learn in the next module in level 4. Now we've got two main kinds of elements, trace metals in soil. The toxic kind to plants and the toxic ones to animals. So these are heavy metals with very high atomic mass that when we inhale or absorb too much, right, our proteins will deform and structure break down from a tertiary and quaternary structure. It can't function and we get diseased, we get sick. Okay, that's the only element here that's not a metal is your fluorine. Now, for those toxic to plants, right, these are okay to mammals like us. So when we have some copper, zinc, that's fine, but to plants it's not good. For this module, you do not have to know the reason why. It's more biology, but biochemistry is always good to read up and tell your friends about it. So what else will affect the toxicity of the metals? The pH, certain redox reaction, and the concentration of the dissolved organic matter. Because if your pH is on the higher side, then you have what? You have hydroxide. You have hydroxide ions that will combine with most of these metals to form the metal hydroxide, and most of them are insoluble. So once you do not have free ions, it doesn't get uptake by the roots, which is still safe. Although you can say that, oh, inside the soil we have these ions, but these metal ions, but they are not freely mobile. You see, they are aggregated together, so they are harmless. So these metals, what can happen to them? They can migrate from a soil to the surface water. They can form into the solid phase, getting precipitation or undergoing displacement, becoming the metallic form. They can move up to the surface and undergoing some reactions, in particular oxidation by air. They could be uptake by plants. So we have come to the end of this topic, and by now you should be able to explain the importance of soil to agriculture, outline the major developments of history of agriculture, soil formation, soil physical and chemical properties, and they analyze the causes, impact of soil erosion and land degradation. And lastly, we also talk about the environmental properties of soil. So good luck. I'll see you in the next class. Cheers.